Okay, this video will cover redox reactions. Again, it's on the chem2 part of the syllabus, and what I'd like to cover here is oxidation states. What are they? How to calculate them? Oxidation numbers. What are half equations and how to write half equations, and then to combine half equations to make a full redox equation. Okay, so let's start off with oxidation states. Okay, now something you have to remember, a few things as reference. Hydrogen ions are always going to be +1, and that is their oxidation number, if you like, their charge. Alkali metal ions are always going to be +1 because they form +1 ions. Okay, so that's that one. Let's just highlight some of these. So yeah, alkali metals all going to be +1. Hydrogen's going to be +1 as an ion. Alkaline earth metals, that's group 2. Their ions are always going to be +2. So for example, magnesium 2 plus barium 2 plus. Aluminium in group 3 will always be +3. Group 4 we ignore because there's a combination of metals and non-metals. We'll look at them as we get them in the question. Okay, now we go to non-metals. If it's fluoride ions, they will always be -1. Oxide ions, -2, etc. And then the rest of them you can work out. And we'll have a look at some examples to see how that's done. If you're given transition metal ions, in the actual name, they will tell you the charge on the ion. So cobalt, that should be 3. Cobalt 3 chloride, charge 3+. Copper 1 oxide, there's the 1. Okay, and therefore that must be 1+. So the oxidation number's 1+ or +1. Okay, right, knowing those reference elements, let's now try to calculate some oxidation numbers. Okay, right, here's some oxidation numbers we can calculate. Let's try doing these. Oops. Okay, let's look at this phosphate ion. Phosphorus and oxygen, overall charge is 3-. Okay, so when you add the oxidation numbers up together, it should leave us with a 3- charge. So oxygen we know as our reference element -2. So we've got -2, -2, -2, -2. There's 4 of them. That makes -8, and therefore the phosphorus has to be +5. So +5 and -8, just a bit of mental maths, +5 -8 makes -3. There we are. So phosphorus's oxidation number is +5. Now look at the sulfate. Can you work out the sulfur here, sulfur there, the nitrogen here, the chlorine here? If you want to pause the video and have a go. Okay, here's the answers then. Sulfur here, so oxygen, we've got 4 of those. That's -2, -2, -2, -2 each. Okay, therefore the sulfur has to be +6. Over here we've got -2, -2, -2 makes -6. These two have to be together +4. Therefore each sulfur is +2. Okay, and that adds up to -2 overall. Okay, over here -2, -2, -2, -2, 4 oxygens, that makes -8. Therefore the chloride has to be +7, because then overall we have a -1 charge. Okay, over here -2, each oxide is -2, that has to be +5. Okay, that's fine. So there you are. There's some ways. That's some examples then of calculating oxidation numbers. Right, now writing half equations. Okay, now when you're asked to write half equations, they will always give you the starting reactant and the finishing product. Okay, so they'll always give you the starting material and the final material. From that, you can write the half equation. So let's have a look at a couple of examples, right? For example, iodide to iodine, and you're asked to write the half equation for that. Manganate to manganese 2 plus, dichromate to chromium 3 plus, iron 2 to iron 3 plus. Okay, I'm going to do a couple of these and then I'm going to ask you to do a couple yourself. So let's do the first two. Now remember, right, so note here, note, okay, a little toolbox for want of a better word, you can use to balance equations. You'll see what I'm talking about in a second. You can use water, hydrogen ions and electrons. Remember that these are half equations and they all take place in acidified solution, hence the H plus, and electrons are traveling back and forth, hence the electrons, and it's a solution, so hence the water molecules. So you can use freely any of these items to balance your half equations. So let's see what I'm talking about. So let's try the first one, the iodide to iodine, and then we'll try this one as well, and then I'd like you to try these two. Right, iodide to iodine, let's do that one. Right, so we start off by saying iodide, leave a little space over here because you're going to fill these things up, and to iodine. Right, first thing you do is you balance the elements, right? So one I, two I's. So we need to have another I on the left. Okay, so two iodides and we got an iodine. Elements are now balanced. We didn't need any water or hydrogen ions. That's it. Now we balance the charges. Overall on the left, can you see there's two minuses? On the right, charge 0. Notice I'm not looking at the oxidation numbers here, I'm just looking at the charge. So 2 minus on the left and 0 on the right. So you can see that it's not balanced. I need to have 2 electrons on my right hand side here. There we are. So now I've got balance the charges and also balance the ions, the actual elements as well. So that's my balanced half equation. Okay, let's look at the other one. MnO4 minus changing to manganese 2 plus. Okay, now here let's look at the elements first of all. So one manganese, that's balanced. We have 4 oxygens and we need to have 4 oxygens on the right over here. Remember our toolbox, we can use water, hydrogen ions and electrons. Water first, always. So we need 4 oxygens on the right. That will have to be in the form of water. Okay, I can write the water anywhere on my right hand side. There's my 4 oxygens now. That seems to balance that, but in so doing I've added 4 times 2, 8 H pluses on the right. So in order to balance that I have to have 8 H pluses on the left. There we are. So from my toolbox I've used water and I've used H plus. Okay, let's just check that all the elements are balanced. 1 manganese, 4 oxygen atoms, 4 oxygen atoms, yep. 4 2s are 8 H's on the right, 8 H's on the, yeah, it's all balanced, all the elements are balanced. Total charges, not the oxidation numbers, the charges on the ions, -1 and 8 pluses. -1, 8 pluses. A little bit of mental maths tells you that that makes +7 on the left hand side. On the right, that's neutral, and I've got 2 plus here. Okay, so there you can see then that the charges are not balanced. So I need to use my electrons, which are negatively charged, to make sure the charges are balanced. So I need to add 5 negatives on the left hand side. Can you see? Okay, so 5 negatives, and that adds up to 2 plus now. Can you see? And so we have the charges are also balanced. So there's my half equation. Okay, so half equation there, half equation there. Right, I'd like you to try the other two, which are Okay, we've done those two. Okay, could you try these two? Pause the video and try these two half equations. Right, if you've done them, let's just check what you've done. So Cr2O72 minus goes to chromium 3 plus. To balance that, 7 oxygens, so I need 7 waters. There we are. That makes 14 H pluses, so I need to add 14 H pluses. Total charge here is 12 plus. Total charge here, oh, hold on. 2 chromiums, yes, 2 chromiums. Total charge is 6 plus. So 12 plus and 6 plus. I need to have 6 electrons. Just squeeze them in there, look. Okay, 6 electrons. Hold on. Need to leave enough space. There we are. 6 electrons. Okay, now I've got 6 plus on the left, 6 plus on the right. That's the balanced half equation. Okay, and the other one, a little bit easier. Fe2 plus gets oxidized to Fe3 plus. Balance that. Elements are already balanced. Charges now 2 plus on the left, 3 plus on the right. So I need to add 1 negative charge on the right, and that is now balanced. Okay, next we're moving on to how to write full equations. Now, if you've got 2 half equations, for example that and that, and you want to join them together, you will make a full redox equation, a full equation. Okay, let's say then that I want to add these 2 half equations together. Okay, so my question will be okay, Cr2O72 minus oxidizes Fe2 plus ions. Write the full redox equation. Okay, now that's the question. The first thing you do obviously is write the half equation, which we've done there, and write the half equation for the iron. So we've done that one, and we've done that one gets oxidized. Okay, so we've done the 2 half equations, and the next thing to do is to add these 2 half equations together. But the rule is that when you add them, the electrons have to cancel. Okay, so for example, let me just tell you what happens then. Okay, here's the answer. Okay, now you see this one here, look, if I was to add that one to this one, on the left hand side of my arrow, I have iron 2 plus over here, dichromate 14 H pluses and 6 electrons, right, just all the left hand sides over here. 6 electrons. On the right hand side I have iron 3 plus and my chromium ions, 7 waters, and 1 electron on the right. 6 electrons here, 1 electron here, they do not cancel. So I have to multiply this equation by 5. If I multiply the left and the right by 5, then I can do that. And then, not by 5, sorry, not by 5, by 6. Okay, by 6, because then I'll get 6 electrons. Okay, if I multiply this whole equation by 6 and then add to this one, my electrons should now cancel. So let's do that then. Right, dichromate Cr2O7 2 minus plus 14H pluses, and I'm not going to write, in fact I will write the electrons, and then I've got 6 Fe's, 6 Fe2 plus. Okay, 6 Fe2 plus. On the right I've got 2 Cr3 plus 7 H2O and 6 of these come on, there we are. And I've also got 6 electrons. Okay, now I wrote them because you can see now that the 6 electrons are going to cancel. So no electrons in my final equation, and that's fine. So that is my full redox equation. Okay, now just let me point out to you the oxidation numbers in these two half equations. Chromium's oxidation number, right, plus 6. Remember, 7 times minus 2 makes minus 14. So the 2 chromiums have to be plus 12. So each one has to be plus 6. Remember, overall 2 minus. On this side, the chromium's oxidation number is plus 3. You don't count the big 2 in front. These are oxidation numbers, not charges. Now, okay. So plus 6 to plus 3. If the oxidation number has gone down, right, plus 6 to plus 3, so plus 6 going down, then that's reduction, right? Now look at this one. Oxidation number of iron. Any single element, the charge on the ion is the same as the oxidation number. Plus 2 there, plus 3 there. Now if you look at this one, oxidation number gone from plus 2 to plus 3, gone up. And so that is oxidation. Okay, so the first equation, reduction. Second equation, oxidation. Together, red ox redox. So this whole equation is a redox equation. Okay, that's where we get the redox, the reduction and the oxidation. Okay, right. Could you now write the full equation, the full redox equation for manganate 7 here, MnO4 minus, oxidizing iodide ions? Okay, I'll write the question for you. Okay, so the question is, okay, write the full redox equation for the reaction of MnO4 minus with iodide ions in acidified solution. Okay, so pause the video and have a go, and then I'll give you the answer. Right. Okay, the answer then, so we got MnO4 minus plus 8H plus 5 electrons, Mn2 plus 4H2O, is that right? 1 MnO4 is 8. Yeah, let's check. Yeah. Okay, and the iodide ions, 2 goes to iodine and 2 electrons. Okay, now in order to add these two half equations, we need to make sure the electrons cancel, of course. So what you would do is you take this half equation and multiply it by 2, and that half equation and multiply it by 5. So then we end up with 10 electrons in each of the two half equations, and the electrons should cancel. Okay, so let's do this then. So we've got 2 MnO4 minus plus 2 times 8, 16 H plus. Okay. Oh, I forgot the iodide. Okay, and 5 times this that's 10 I minus. Okay, just going to write it down here. The right hand side, 2 times that and 2 times that. And then 5 times iodine and 5 times the 2 electrons. So 5 iodine and 10 electrons. And you notice that the electrons cancel there and there, and then you have your full redox equation. Okay, let's just look at the oxidation numbers again, just over here in our final in our half equations. Manganese +7 oxidation state to +2, oxidation state +7 gone down to +2 reduction, and the iodide -1 to 0. Any element in its normal state at room temperature and pressure, oxidation number 0. Okay, so -1 to 0. It's gone up, that's oxidized. So we've got reduction here and oxidation occurring here. So reduction, oxidation, redox as your final equation, as your final full equation. Okay, and I think that's it. That's that one there.